Okay, so tomorrow, like I said a second ago, your quiz is going to have 10 questions. I want you to erase number 4. We're not gonna go over it, and then also all those on the right of number 5. Go ahead and mark those out. I don't want to deal with negative exponents on the quiz. So here we go. Let's get started. We have got through this in every class, so I don't foresee us not being able to get through it in here either. Okay. So number 1, they want you to all from this table. Well, kind of. They want you to answer the following questions. 1, does this table show exponential growth or decay? Well, again, there's one simple thing you look at. What do we know about growth versus decay? The values will what with growth, and they'll do what with decay? They'll increase with growth, and they'll decrease with decay. Well, what is this table clearly doing? They're definitely increasing. So this one is definitely showing exponential growth. Now, with that being the case, the next question asks you, which of the following could be a function to model the data? It's not going to model it perfectly, but out of the 4, which one would model it the best? Well, let's go ahead and eliminate what it can't be. Okay, think about this. What's the base of that exponent? Is that growth or decay? 1.7. Growth. Remember, decay means less than 1. So even though it's a decimal, it's greater than 1. So it would show growth. So don't cancel that one out yet. Look at B. What's the base of it? Growth or decay? Growth. Leave it. Okay, look at C. What's the base of your exponent? 0.7. Growth or decay? That one's decay. So could it possibly be C? No, because this one you already told me it shows growth. And then finally, is this even an exponential function?
No.
That's a quadratic. It's x squared. That shouldn't even have been there. Okay? No brainer. Hopefully you guys see that. Okay, so we're between A and B. Now, if you want to take an educated guess, maybe you would say one or the other. But what's really the thing that you should do here? Yeah, go to your calculator and graph them and look to see in your table which one mirrors that data the best. So let's go to our graphing calculator and see. I'm going to reset my calculator because it's been doing a bunch of stuff today already. So I'm going to go to y equals, and I'm going to enter this first one in. It's 1.7 raised to the x, and then on the outside, plus 8. Now, you can look at the graph if you'd like, but what you really need to focus on is the what? The table. So I'm going to look at the table once I've entered that. And I'm just going to kind of take a quick comparison. In my calculator, 1 matches up with 9.7. But in my table, 1 matches up with 3. Am I off to a good start or no? Yeah, I wouldn't say this is good. At, let's say, 4, it's 16 in my data. And on my paper, 4 is 22. That's a little closer. And then 7 is 49 in my data, and it's 92 in my paper. Are those very close? So I'm not liking A very much. So let's try B. Hopefully it'll be a little closer. So I'm going to enter this one. It's 2, open parentheses, 1.7, close parentheses, raised to the x. I'm going to look at that table now, and let's see if it's a little better. At 1, it's 3.4. Is that pretty close? At 4, it's about 16.7, almost 17. Is that pretty close? It's not too bad. At 7, it's 92. And at 7 up there, it's 82. So is it a perfect match? No. But between the two that show exponential growth, which one does it have to be? It has to be B. So go ahead and mark B. Now, go ahead and look at the table for B. Or the graph for B, I'm sorry. This one asks one more question. If this really did model the data that we have on the right, what is happening as my end behavior is approaching negative x, negative infinity? As x is going off to the left, what's y approaching?
Decrease.
It's definitely decreasing, but what's it decreasing towards? Is it decreasing towards negative infinity? Or is it decreasing towards my asymptote?
Asymptote.
And what is that asymptote?
0.
Y equals 0. So it's going towards 0. So the answers that we should have on our review is B for number 2. And then it's approaching in 0 as x is going to the left. Okay? Now 4, I wanted you to cancel that one off. That one's not going to be on the quiz, I promise you. And that's the first question. Okay? On the quiz tomorrow, that's number 1. It just has 3 questions all for number 1, I think. I'll go back and look, but I think that's right. Okay, number 5 should be another easy one. You're supposed to see which one represents what?
Decay.
No, I'm wrong. Those first 3 problems are the first 3 problems. It's not 3 problems for number 1. Does that make sense what I just said?
Is there 10 problems of like?
Very similar. Yeah, like almost identical. Okay, number 5. It says to mark the ones that model what?
Decay.
Decay. Now, do you have to graph all these?
No.
No. Look, what's the base of this exponent? Is that growth or decay? Growth. Don't mark it. What's the base of that exponent? 1/2. Is that growth or decay? Mark it. What's the base of that exponent? Growth or decay? Mark it. What's the base of this exponent? Growth or decay? Don't mark it. So the only 2 you should have marked are B and C. On number 4 tomorrow, I know it says 5 here, but on 4, we marked out number 4. On number 4 tomorrow, this problem, it asks about which ones are exponential growth. So it's just the opposite. Okay, if this one had asked me growth, I would have checked A and D. All right, it's just as easy to see. Yes.
Wait, so what if it's negative? Is that?
That's why we mark those out, because I don't want that to be a part of the quiz. But it's basically the opposite. Like, if it were negative,
Yeah, maybe.
okay,
Yeah.
it just reverses it
Yeah.
essentially.
There's not going to be negative.
There's not going to be a negative one. I wanted to leave those off the quiz. I wanted us to focus on the stuff we've talked about. So, that's all for that problem.
Will we
Okay?
like go over that eventually, or?
Maybe, and if we do, we will. But I don't know yet if we'll cover that or not. Okay, so this one, they want us to take the parent function 4 to the x, and they want me to take the specific transformations that they list and add it to the equation. So it starts with shifted 3 units down. Where does that happen? A, H, or K? Out front, in the exponent, or down to the side? K, down to the side, right? Remember, it's A, H, K. It happens in K. Vertical shift happens in K. And what do we say about it? It is what it is. What do you think down 3 means? So we're going to put minus 3 down to the side. That's what that represents. Okay? Next, it's reflected across the x-axis. Where does that happen? That happens out in front in A. And what does it look like if it says it's reflected? It has to have a negative. And lastly, it says it's vertically compressed by a factor of 1/2. Where does that happen? Also A. So it's going to be paired with that negative. I put the 1/2. So it's negative 1/2 times 4 to the x, and then minus 3. Or you could have just as easily put negative 1/2, open parentheses 4, close parentheses to the x, and then minus 3 down to the side. Whether you use the times or whether you use the parentheses to represent A, B, and K, your call. Okay? Either of these would be 100% correct. I like it like this. Visually. But they're both completely right. Okay? If you look at number 7, it's the same, it's just opposite direction. They give you the equation, they want you to list the transformations. Now, how many transformations have we said you could have? You could have 4. So guess how many blanks there's going to be? There's going to be 4 blanks.
4.
Now, do they all have to be filled out? No, only the ones that exist have to be filled out. So let's see what exists in this problem. You got a 3 out front. What's that 3 tell me out front, Frey? It's going to be a vertical stretch. Vertical stretch. There is no negative out front, though, is there? So there's no what? No reflection. But there is an x plus 2 in the h spot. Remember what that's representing? Horizontal shift, right? And what do we know about it? It's the opposite. So since that looks like a positive 2, it's actually a negative 2 horizontal shift. What is the direction of a negative 2 horizontal shift? So this one's going to shift left 2. Shifts left 2. You got to tell me the direction. You can't just say shift 2. You got to tell me it shifts left 2. Okay? And then finally, we have a K out there, which represents my vertical shift. And what do we say about it? It is what it is. So what direction is minus 2? Vertically. So it shifts down 2 as well. So please remember, when you name these, you have to be specific with the direction. You can't just say shifts 2, shifts 2. It shifts left 2, it shifts down 2. Okay? So you'll have a question like that, very similar tomorrow. It's number 6.
So all of it doesn't have to be filled out.
Yeah, there will definitely be 4 blanks, but you only have to fill out how many transformations happen. Could be 1, could be 4. Okay? There, I will tell you, there's three. Okay, there's 3.
There's 3.
3 of them, yeah. There'll be 4 blanks, but there's 3. There's 3, so it's very similar to this problem. Okay? Okay, next question. It says, which function has a higher y-intercept? And there's 2 really good ways to do this problem. Logically, you could probably figure it out, but the safe bet's going to be the what? The calculator. Okay, we'll go to the calculator first, but here's the logical side of this. What controls the asymptote and where the graph is? The K value. What's the K value for this one? So this thing's shifting up 7. You see that? What's the K value for the other one? This thing's shifting down 4. Which one do you think is going to have a higher y-intercept? The one that shifted up 7, right? I'm going to assume it's this one. Okay? I'm going to assume it's that one. However, I would recommend you go into your graphing calculator just to make sure. Okay? It can't take you long to type this in, can it? Somebody say no.
No.
It can't take long, okay? So I would just go over here to y equals. I would type the first one in. You got negative, open parentheses. Oops, go to y equals. Clear it. Negative, open parentheses. I'm going to use alpha y equals number 1 to do 4/3. Close parentheses. Raised to the x plus 2. And then down below, plus 7. And again, you're welcome to look at the graph, and you can probably see it. It looks like it's going through just at what? Really close to what y-intercept? To me, it looks really close to 1, 2, 3, 4, 5. So I'm going to look at my table. Remember where to find the y-intercept in your table? Where x equals 0. Guys, what's 47 divided by 9? 47 divided by 9. All right, we got it right, 5.2. So this one has a y-intercept about 5.2. Let's look at the other one. Go to y equals, clear it, and type in alpha y equals, number 1, 1/2, open parentheses, 5, close parentheses, raised to the x minus 2 inside the h spot, and then minus 4 outside. So this one shifted down 4, and sure enough, where's it cross the y-axis? Way below 5, right? Way below 5. So were we right? We were right. Now again, if you want to look, second table, it's where x equals 0. Well, x equals 0 at negative 3.98. Yes, we were right. 5.2 is much higher. So you're going to have one of those on the quiz tomorrow as well. Should be real simple, right? Real simple. Okay, next. Let's just keep it here since it's a graph. And let's type it in. Y equals, clear that out, 2 raised to the x plus 5. Idiot. I'm talking to myself, by the way, not y'all. X plus 5, and then scroll out. Ugh. Fat finger problems. Minus 4. So I can graph it if you want to look at it. Let's answer some questions with that. Domain. What do we say domain always is? Will it ever stop going left or right? So what do we say it was, Margaret? It's negative infinity to positive infinity. Never stops going left and right. But does it ever stop going up or down? Well, it can't go past your what? It can't go past your asymptote, right? And what did my asymptote move down to? So my asymptote is y equals negative 4, right? So therefore my range is everything from negative 4 and up. So that's from negative 4 to infinity. Are y'all looking at your graph? That's what you should have so far. Now go back to the graph real quick. As x is going to the right, look guys, as x is going to the right, what's y doing? So it's approaching infinity. But as x is going to the left, what's y approaching? Your asymptote. What is your asymptote? Negative 4. And the last thing that we have to answer before we graph it is, what is my y-intercept? How can I find that? Real easy. Everybody remind me. You look at your table where x equals 0. It can't be easier than that. Okay? So my y-intercept is 0.28. Okay? My y-intercept is 28. 0.28. Now, let's just graph this thing. Let's see what we got. I got some pretty good points here. I got negative 5, negative 3. 1, 2, 3, 4, 5, negative 3. I've got negative 4, negative 2. I've got negative 3, 0. And I've got negative 2, 4. Are all pretty good ones. Especially knowing, let's go back to our graph now. These are all pretty good points, especially knowing that my graph can't do what? It can't go through a point. Oops. It's like an invisible line right there, isn't it? You can't draw your graph below y equals negative 4. So I'm going to hug that negative 4 line and then start increasing it through my points. And now we have a pretty good looking exponential function. The problem like this on the quiz tomorrow has all of the same identical questions. It has a graph that you need to do. It'll ask domain, range, and behavior. It'll ask you about y-intercept and the asymptote. But I'll tell you this, the graph on the quiz tomorrow is an exponential decay, where this one was a what? This one was a growth. The one tomorrow is going to be a decay. I'll go ahead and tell you. So really what's going to happen? What will change? Because it's decay. What's the only thing? The end behavior. They'll just switch, right? So you guys should be able to do really well on that one as well. Now, I did not put one like number 10 on the quiz But I wanted to just talk you through it real quick, just to make sure and just like really hammer this point in. What controls the asymptote? The K. Which of those 4 questions have a K value of 4? I know there's a bunch of 4s there, but which one actually has a K value at 4? D. Look, there's no K in A, B, or C. The first time you have that K value even present is D. That's the one where the asymptote would change. Okay, the asymptote for A, B, and C would all be y equals 0 because none of them changed. But that last one did. So I wanted to just get that one into your brain, but there will not be a question like that on the quiz tomorrow. Okay, I don't know why I left it off, but I did. Okay, now there's 3 questions from this last group of 5, and if I were going to pinpoint the ones that I would focus on, it would be 11, 12, and then I guess you could really have your fill of either of these 2, 13 or 14. I actually didn't even put one like the challenge problem. I don't know why. But anyways, let's start with number 11. There will be one question on here like this, where all the bases are already good to go, right? But you got to do what with one side? You got to combine, right? See, on the left side, you have 2 bases of 5. So what allows me to combine those where I'll only have 1? What will allow me to combine those where I only have 1 base of 5? I have to do what with my exponents? I have to add them, right? Just like this. So what are those 2 exponents? And? So how would I combine those? What's 3x and 2x give me? And what does negative 1 and negative 5 give me? So those combine to get 5x minus 6. So we made those bases the same by combining those exponents, and that left me with 5 to the 5x minus 6 equals 5 to the x plus 6. I didn't have to do anything on the right side, did I? No. So what's the deal now? Once you get your bases the same, drop them all. So 5x minus 6 equals x plus 6. Now what? I'm going to subtract that x. So 4x minus 6 equals 6. I'm going to add 6. What's 6 plus 6? And then finally, I'm going to divide by 4. What is 12 divided by 4? So x equals 3. You're going to have one that's very similar to that problem tomorrow. Okay? Very similar. Okay, let's go to number 12. You're going to have one very similar to 12. In that only one of the bases have to change. Let me show you why. 64. Can I make it an 8? Sure I can. 8 times 8 is 64. So 8 to the second power. So I'm going to change 64 to 8 to the second power. Don't forget, you already had an x there. We'll deal with that in a second. But have we created our bases to be the same? So I'm going to cancel those bases. What is 2 times x? So 2x equals 3x plus 1. You got a couple of options here to solve this problem. I'm going to go ahead and subtract 3x. What's 2x minus 3x? So negative 1x, or negative x, equals 1. Am I allowed to leave my answer like that? No, you got to move that negative. How? You divide by negative. Okay, or negative 1 technically. But when I divide by negative, it's just going to change the sign on the other side. So x equals negative 1. So you have one similar to that, where you only have to change one base.
What was the answer to
Number 11 was x equals 3. And then you're going to have one kind of like 13 or 14, where you have to change both bases. It's really more like 14. You're going to have to change both bases, and one of them will have a negative exponent. So like, for example, with this number 13. You think about your smaller base here, 6. I can't get to 6 any other way. If I tried 2, 2 times 2 is 4 times 2 is 8, went right by it. If I tried 3, 3 times 3 is 9, went right by it. So 6 has got to be my number here, right? So let's see if 6 will give me 216. What's 6 times 6? What's 36 times 6? So sure enough, 6 cubed gives me 216. But that's not 216, is it? It's 1 over 216. So it's not 6 cubed, it's 6 to the negative 3. Does everybody understand that? 6 to the negative 3. So, here we go. Did I create my bases to be the same?
Yes.
So I can drop off my bases, and negative 3 equals 6x plus 12. So what do we do from here?
Subtract the 12.
What's negative 3 minus 12?
Negative 15.
Negative 15 equals 6x. Last step.
5 by 6.
What's negative 15 divided by 6?
2.5.
Negative 2.5, right? Negative 2.5 equals x. And that's it. That's all there is to that problem. Questions about that one? Pretty straightforward, right? Pretty easy. All right, number 14. This is more like the one. You have to change both bases and one of your base will be negative. Okay, for example, what base am I going with? 2, right? So on the right side, it already is kind of a 2. It's 1/2. So that's not just 2, it's 2 to the negative first. Now let's figure out what the left side could be. 2 times 2 is, 4 times 2 is, 8 times 2 is, 16 times 2 is, there it is. It took me how many times? 5. 2 to the 5th. 2 to the 5th gives me that 32. And you already have the x plus 6 up there. So here's what it looks like right now. 2 to the 5th, with that x plus 6 already up there, equals 2 to the negative first. Now the bases are the same. We can cancel them. So what is 5 times x? And what's 5 times positive 6? So 5x plus 30 equals negative 1. And from here, it's pretty simple, isn't it? We subtract 30. What's negative 1 minus 30?
13.
And then finally,
35.
not subtract. Divide by 5. We break it away from the x by dividing. And you get a funky answer, kind of. That's nice. Negative 6.2. It's a nice decimal. It's not too bad, is it? So that's how you do number 14. And that one's more similar to the last problem on the quiz than even number 13 was. And then I know this is a challenge question. It's actually, y'all probably not going to think it's that challenging, really. The only thing is, the reason it's called challenge is you have to change both bases. Think about it. You can't make 81 have a base of 27. So you got to make 27 and 81 have the same base. So what's the only base that you can get to 27? 3. 3 times 3 is 9. 9 times 3 is 27. So to get 27, we got to do 3 what? 3 cubed. And you already had the 3x up there. So let's keep going. 3 cubed was 27, right? Well, what's 27 times 3? There it is. So we only had to do 3 to the 4th to get 81. And you already had the 2x plus 1 up there. So does everybody see how I did that? We did 3 cubed to get 27. We did 3 to the 4th to get 81. Now we have the same bases. We drop them all. What is 3 times 3x on the left side?
9x.
And then on the right side, what's 4 times 2x? And then what's 4 times positive 1? So you distribute that and get 8x plus 4. And this is actually pretty simple. Don't we just subtract 8x? What's 9x minus 8x? It's x, 1x, or x equals 4. And that's it. That's all there is to it. That is our review for your quiz. Your quiz tomorrow will have only 10 questions. They will be this simple. I don't foresee you having any issues whatsoever. Does anybody have any questions?
Will it be the same?
It will not be exactly the same, no. I will change the questions. But, I mean, what you're looking at looks so much like the quiz, it's not even funny. It just has a couple of less questions. Because I deleted 4, half of 5. I didn't do one like that. One on the back I told you. And then there's only 3 instead of 5 questions. All right? I'm going to close this review off. And then if you have any more questions, you can ask.